connections. Top boss, let me know, what do you know about this important session or this important lesson when it comes to solar? Very, very important indeed. And if you know about it, then it definitely means that you are a step ahead, my top boss. Mhm. When it comes to electrical installation, especially when we talk about solar, inverters play a key role. What I have here is a 1 kilowatt inverter, and it is already connected. And very important, if you may see, is that it has the connection where you have solar coming in and you have the national grid as well. And let me just move my camera closer so that you can be able to see what I'm talking about. So what we have on this screen, I would like to call it the LCD screen, is definitely charging it here. Now I'm going to definitely disconnect the grid as well as disconnect solar, so that we only remain with the battery connection. And finally, I will disconnect the battery, and then I will redo the whole process, so that I'll be able to share more when it comes to that. Now, to begin with, when you are disconnecting it, the first process is to first disconnect the solar panel. You can also disconnect the AC so that you are remaining with the connection for the battery and the connection for the load. And then finally, you can switch it off, and then you can have the battery disconnected. Young Javi is saying, is that a hybrid inverter? I would say no. Um, Young Javi, good to see you. Thank you so much for joining in. Daniel Elegant says hi to you. George Onyango says, I'm waiting for the upcoming lesson. Thank you so much. Glad to have your attention, my top boss. So let us go right into it. This inverter is a 1 kilowatt inverter. It comes from must have supplied a lot of inverters, at least in my country. That is what I know. And yeah, so they have done a very good job. We have plenty of inverters, and what I have here is definitely must. So I'm going to disconnect first solar incoming power, and that will be so simple for me to do it. Now what I do is first open this case at this point so that I may be able to showcase to you the connections in this inverter. So I'm using it as a power backup in my shop, and the electricity or the national grid is connected to this inverter here. So for you to remove this cover, first of all, things need to be off. But since I'm very, very cautious, I just want to, demonstrate to you how it is done, as it is already on. Victor says, hello, boss. Thank you so much for joining in. Nelson Walishimba says, you are doing a good job. It is truly helping in Zambia. Victor, thank you so much for your feedback. Removing that case, what I exposed to you here is very, very important, my top boss. We have this section that has connections for the incoming AC and the outgoing AC. We also have the incoming DC, that is definitely the battery, and we also have the incoming, which is solar. Those cables that I have used there are very wrong. What we are going to use is this flexible cable here. As you can see, has very important features. The first one is this sheath, which is definitely used for earthing. So if you have this cable from the solar, you find a lot of application in it. So you can connect the negative and the positive. The solar has the negative and the positive. That is what I'm having here. And then you can use this sheet as earthing so that you can be able to earth your solar panels and connect that to the ground. Thank you so much for the likes. I see you, and also for engaging in this live stream. I see the comments that are coming in. You saying hello to me means a lot, my top boss, and I'm thanking you so much for finding time to be here. Joshua Mutinda, I see you, says hello there, top boss. I'm tuned from Tala, Machakos. Incredible. Good to see you, Joshua, and welcome. So I want to disconnect PV. PV is basically solar. Before I do that, there are two fans here that I will be talking about them shortly. I'll disconnect PV, I will then disconnect AC, and then finally I will disconnect the battery. And throughout the process, I will be sharing more information about that. So if I disconnect PV, you will not see this sign, the solar here, because I've disconnected this solar of ours. I'm using this one. It is indoors and it is still charging my battery. So what you need to know is that if the PV is in, you can be able to have this sign here. This sign is DC to DC, meaning the DC that is coming from the solar generates DC. It converts the sunlight to DC, and then the inverter will definitely figure out how to charge the battery using the power that is harnessed from the solar panels. And the same thing happens with the grid that is. So once the panel is disconnected, that is what you get. You will not see the incoming supply from the solar, definitely the PV that is. So once disconnected, what we have here is definitely the battery being charged from the national grid. So I want to disconnect the national grid. We'll notice that this part will definitely not be there. All right. So shall we do that? And another indication that the national grid is missing is definitely what I have here on the side. I have the AVS. The AVS is on, receives the coming power from the national grid, and then it feeds the inverter, right? So if I switch it off, the incoming national grid supply, we will definitely not have this, but we will have the output or the AC supplied only or fed by the battery, right? Now, what you need to notice here is that the AC or the national grid, as indicated by that tower, is actually providing a throughway or a bypass to the load, and at the same time it is charging the battery. So it is doing like two at the same time, providing the output, prioritizing the load, as you can see the indication of that bulb there, the arrow coming in straight, and then the dotted line goes to inversion, so that AC gives an output of DC through the inverter conversions. What is normally used to achieve that? Is it the rectification? How do you obtain DC from AC? So let me switch AC that is incoming off. You'll see that here you will notice that it will go off. But most importantly, I think we need to focus on our inverter, so that we'll be able to notice that correctly. Able to see that perfectly. So let me just switch AC, the incoming AC off, and then we will definitely not be charging our battery, and at the same time we will not be having the supply, right? Makes sense? Okay. So that beep is definitely an indication that AC is out. Remember, it is the incoming AC, the AC that is used to charge the battery as well as give an output to the load. That being said, it doesn't mean that our inverter or the output is off. It is still on, as you can see, AC or inverter blinking, meaning that it is giving an output, an AC output. So now we switch it off before we disconnect the battery. All right. So there is a switch just on the side here. Gives that beep. Once it gives us that beep, it means that the inverter is off. But again, you need to remember that the battery here is definitely connected. So using my digital multimeter, I will switch it to DC and then determine the voltage that is coming from the battery. So DC at 20, because my battery is a 12-volt battery, and just get rid of that hold. Placing the probes on the incoming of the battery, we have 13 volts, that is DC. So my battery is definitely fully charged. So I have to disconnect it. Now, disconnecting the battery, you disconnect a terminal at a go, or you disconnect one at a go. So, and I have already been requested by my top boss. Top boss has requested me to demonstrate the connection, one by one connection, and I'm going to do exactly that. George Onyango has said, my great teacher, can you please take me through the whole connection from the start of inverter? That is what you are going to do, my top boss, George Onyango. Thank you so much for that. Thank you so much for tuning in. I see the likes and I appreciate that. Let me first of all get rid of that LED. So my trunking here is supplying. So what you see from that is that these cables are feeding the inverter the voltage that is coming all the way from my battery down there. So the battery is down there, right? So here is the battery, positive terminal, negative terminal. The battery itself is 12. Do you think it is important for me to take the camera closer? Yes, of course. I pause. So from the inverter, it goes all the way. Those are the cables. You notice that the cables are completely different from what you are used to, meaning the AC cables. And we need to do something about these cables definitely. And the lagging is not properly done. We're going to do it shortly. So what we need to do in this scenario, so you can see these are 25 mm cables. There is something very special about these cables, right? So at the inverter section, what you have is those cables connected there for the battery. You know, we normally have the connection for both the AC and the PV. So PV plus, PV minus, that is where the solar is incoming, and I will be connecting that and showing it to you. This is definitely the fan cooling system, right? And then we have DC. Now this is the connection for the battery. Notice how different it is, very huge compared to the PV, all right? Because it has to have minimal resistance, okay? Another important thing, it has to accommodate the size of the cables, because the DC requires larger size of cables. Who knows the reason behind that? Why should DC have large sized cables as opposed to AC? Even in transmission, you find that the cables are not that big, no. So the AC output is connected at this point. The AC input is this one inside here, together with earth connection. I'm going to disconnect all of that so that we can connect them from the start. We also have the second fan, and all of these fans have important functions. Another important thing that you need to know is this polythene paper. This polythene paper concentrates the airflow so that the air is not scattered, so that the intention of each fan, like for this one, which is supposed to drain the hot air generated from the conversion of DC to AC, is concentrated from the IC or the integrated circuits all the way out. And notice another important feature of the inverter is definitely these airways, or the airwaves, I mean the airways here, so that once the inverter is operating, it has to draw, you know, air from there and pumped out. So they are not supposed to be blocked in any way. All right. All right. So now for me, what I'm going to do is to first of all disconnect here, so that the inverter will completely be isolated from any source of power. And I will simply do that by, you know, disconnecting those terminals there. And then I will do a good job at cable lagging using our tool, which is a very important step when it comes to electrical. Why? Because electrical connections need to have minimal issues when it comes to, you know, terminations, so that we may take care of resistance. Don't want to have issues of resistance. Loose connections are definitely a recipe for disaster, as we normally here at Top Heights Electricals and Electricians. So first of all, disconnect at this point. So I will start with the positive. I'm a firm believer that the neutral should never be applied the same when it comes to DC connectivity. I don't know about you. I don't know how you do it. So we start with the positive terminal, my top boss. Remember, our inverter is off. Therefore, we don't need to worry. So having disconnected it, we also go ahead and ensure that we isolate it in a manner that it will not short circuit. It's also very important for you to avoid placing anything on top of the battery. Why? In the event that these terminals short circuit, then you'll be reducing the lifespan of the battery. So you need to be very careful. As you can see, my battery is free from any interference. It is free from anything that is placed on top of it. I intentionally avoid that. Nothing should be placed on the battery, be it an insulator, nothing. The key word here is nothing. So that is the rule that I stand with, that nothing should be placed on top of this battery. So once that is the rule that we go with, it means that for someone who doesn't have a clue about the battery operation and anything that could short circuit it, they will definitely know that the keyword is nothing. So you not have any incidents of short circuiting. Again, using our digital multimeter, what I'm going to do is to definitely check, the voltage that is that our battery is actually having. So good to see so many of you here, my top bosses, and it means a lot to me. So using my digital multimeter, very important for every electrician to have it, my top boss. I have placed it at 20, and then placing the probe, a red probe on the positive terminal of the battery, the black probe on the negative terminal of the battery. What do we have? We have, sorry about that, we have 13.2, the same that we recorded at the inverter, meaning that there are minimal to no losses due to this volt cable here. But I'm not saying that I've tested the resistance. We have not done the resistance test. We have not done the current test. But from the look of things, I think we are doing well. We are doing okay. I have my top boss Onyango saying, following you from Mauritius. Thank you so much. Daniel Elegant says, following from Nigeria. My Nigerian people is in the building. What an honor to have you, my top boss, joining in. Thank you so, so much. This battery is a Nipotech battery, and it is actually 200 amp hours. It is a lead acid battery, lead acid. The solar, very much possible, but that system will happen. Electrician, good to see you. Say hello, Mr. It's me, Nathan Kaigulo from Uganda. Thanks, I'm late today, sir. No, you're not. So glad to have you. David Moch says, following from Denmark. Thank you so much, David. Such a great honor to have a top boss like you from Denmark. All right. So we continue with our today's session, and like I promised, I would want to, do a good job when it comes to these crimping. Is it crimping? Now from the inverter cannot give us any output to these cables. Why? Because we don't have AC coming in. We also don't have DC coming in from solar, and therefore we do not have any power that is generated. Now, if I take this digital multimeter here and then place the probe at the positive terminal going to the inverter, and then place the red probe, the black probe, we get a reading right there. Why do we have a reading? This is from the inverter. And remember, the inverter is not connected to PV or solar. Inverter is not connected to AC, but we have some reading, and the reading is reducing slowly by slowly. Who knows what is happening here? Let me know in the comment section, my top boss. So good to see so many of you. Thank you so much. So let us crimp those lugs. I am using this crimping tool, right? Crimping press. We have those that are hydraulic, but mine is not. So I'm going to use it to crimp, my cable lugs. They were not well done. And if the cable lugs are not properly done, then there could be an issue because you might have a loose connection incident. Now, loose connections when it comes to solar, they are not good because it means that you will not achieve maximum charge. You will not have the maximum conversion of power or solar from the sun. The sun rays that you get from the PV panels, right? So I'm using my crimping tool to ensure that I crimp it. So yeah, so thank you so much for joining in, my top boss, despite the late notice. Most of you didn't know I would go live, but here you are. So thank you so much for that, for joining in, my top boss. Right. So using the correct tool is very important. Crimp it like that. Crimping the cable lug, ensuring that I tighten it completely until we are good to go. So how is it looking like? Look at that work, top boss. Can we crimp to this point as if it's not even turning, meaning that work is really impressive. It's 25 again. We add another crimp it as well. So you be the judge. What do you think about it? At least it looks completely different. My crimping tool doing the most. So if you try to turn it, nothing is happening. If you try to get rid of the lug, the cable lug, it is difficult. When you see that, it is an indication that indeed that job is well done. Now we go to the neutral. sorry, not the neutral. I've really been used to AC installations, AC wiring. So at that point, you will notice that the lagging that I had previously done without the crimping tool was shoddy, was bad, and most people do this, and this is very, very bad. Daniel Elegant says, Top Boss, please explain why we have reading from the inverter while it's not connected to and form of power. Yeah, to any form of power. Absolutely. Now, an inverter has capacitors. Those capacitors that were connected, in a parallel with the are the ones that are discharging slowly. So before I reconnect to the battery, we will also take the reading and establish. Previously, it was around 4.5. We'll see, is it completely discharged to zero or what? But that is a very good question, Daniel Elegant. Why do we have voltage coming from the inverter yet there is no source of power? All right. All right. So again, we crimp the neutral at 25. That is what we have. As you can see, things are turning up very well. Turning up very well from this point. That is what you can see. The lag is being crimped properly. You can also add the point where we can crimp it as well. Go on again, and we have it. Oops, sorry about that. Just had my crimping tool full. Yeah. Frank YF says, please, Top Boss, I will also appreciate you explaining how to determine the number of panels and the size for any project. Absolutely. I'll be guiding you on that in my coming videos. But for today, let us focus on inverter installation connection. So we began this live stream by demonstrating how to disconnect the inverter, from connections that are from PV, from solar, from the battery, the AC. We disconnected step by step, and there's a reason why we do that. So we disconnected everything, and our inverter is completely disconnected from the battery. It is disconnected from AC supply as well. Okay. So let me take you back to the inverter, my Top Boss, if you don't mind. Take you back to the inverter so that we may continue with that session right there. So that is just the cover. There we go. So my Top Boss, what we have here is definitely that connection. I don't know whether you'll be interested for me to open the inside of the inverter. Let me know. Our inverter is off. We don't have the supply from the battery. I've already isolated it. Don't have the supply from the AC. We are going to isolate it as well. If you're interested, let me know. Just type yes, and then I'll be able to disconnect it. Features of an inverter, especially the inside of an inverter, is purely electronics. A lot of electronics for us to learn. And if you indeed say yes, we should access the inverter and be able to see how it looks like in the inside. I will definitely do that. I have Frank YF says yes. Chris Wambugu, good to see you. You are saying yes. Incredible, incredible. If I get 10 more people, I mean, if I get a total of 10 saying, kindly let us see the internal of the inverter, I will definitely do that. Should we access the circuit of an inverter? Do you think it is helpful to you as a top boss? Is it something that you would be interested in? If you say so, we definitely do that. So I have 4 yeses. Should we access the internal, the circuit of the inverter? Regerin, game over. Good to see you. Daniel Elegant, please open the inverter. Awesome. George Onyango, please open the inverter. That's the thing, man. Ngui Dennis, how are you? Saying yes. Should we access the internal of this 1 kilowatt inverter and see how it is and learn a thing or two? So I have how many yeses? I have 1, 2, 3, 4, 5, 6, 7, 3 to go. If I get 3, we access the inverter internally and learn. That means removing this case and be able to see the inside of it. Can we have another 3 yeses? All right. So the inverter is a very important system in our home. It is especially for those who have the solar system. Chris Wambugu says, I'm doing an exam tomorrow on electrical installation and there will be a question on solar installation. So it will help me so much when opening and explaining on the inverter. Absolutely. Because of you, my top boss, Chris, I will not even wait any longer. I will simply open it. If you have an exam, then it means that it is urgent. These are very urgent matters. So I begin by accessing that screw right there. So just a moment, let me get rid of these. Let me move this panel to the side. Bear with me kindly as I move these so that you can be able to access the inverter, be able to learn a lot. It's our moment to learn. And thank you so much, my top boss, for taking your time to join in this live stream. It means a lot. I see so many of you joining in this live stream. So we have screws on the side, and what you can see is several connections there. So you have these screws. On this side, we also have vents, have screws. This is the switch where you turn it on and off. And also on the side, we have screws all over here. All right. Okay. So remember, we are very safe doing this work. The inverter is off, not connected to battery, not connected to solar, and definitely not connected to AC, the incoming power. I'm just getting rid of all of these. Top boss, if so, you can get rid of that case, isn't it? Apologies for that mishap. So if you get rid of it, simply lift it like that. Then that is what we have. So we have this point here where we have the LCD, we have the controls, and there is that, the connect right there. So this is definitely the circuit that has the buttons, or the motherboard, smaller motherboard with the buttons, where, as you can see on the side, you have the buttons. So this is definitely the control. This is what houses the LCD, and all of that is connected all the way to the inverter through this cable here, right? Trying to see whether we can disconnect the cable. I don't know. I think I had disconnected it some time back. I'm not sure about that, but you'll forgive me. Let's just place it over there so that we don't quite disturb it, right? Is it visible? So that is how the inverter looks from the inside. You can see there are capacitors. This small motherboard here definitely has the USB attached to it, the connection for port connection for the internet or the Ethernet, and the other USB type. So it is also linked to the main board. So this is definitely the main board. We have controls in here. This section, as you can see, is the incoming AC. The incoming AC undergoes the conversion to give out a DC. All right. So the DC definitely is what flows through this part here to charge the battery down there. All right. This section also is concerned about the PV, as we have the PV that is connected here. And solar panels, when they are connected, whether in series or parallel, they will definitely be connected at this point, and they will definitely be charging our battery as well. All right. And this is the polythene paper that I was talking about. Very, very important. It helps the flow of air to be concentrated. From this section here, the outside part where you have these open airways, as well as here, they will definitely be pushed out. So these two fans, so if there is charging that is happening, you will normally find that these fans are definitely operating. If the load is connected, probably, and one fan is running, it definitely means that it has to cool down the AC, the IC, the integrated circuit. And so in many cases, you'll find that the fan, the fans don't run concurrently, the two fans. You find that it is only one fan at a go. So what we see here is a lot of heat sinks. In total, we have 1, 2, 3, 4. We have 5. Uh, Inside there, I don't know whether you'll be able to see, we have several uh, heat sinks. Okay. And all of these, as you can see, have this paper on them. Now, what happens if at all someone was repairing this inverter and then forgot to, put this paper back? That is a huge disaster, because the flow of air will not be concentrated to these heat sinks. These heat sinks definitely are cooling the integrated circuits. All right. All right. So more of information about these I will definitely be sharing, but we also need the knowledge of someone who is conversant with electronics. Electronics was a little challenge for me. I only mastered electrical, right? So there are a lot of circuits here. I will just refer to them as ICs, or integrated circuits, control circuits, capacitors. What is the function, the key function of a capacitor? Who knows? Who remembers? All right. So my top boss at this particular point allow me to demonstrate how to install an inverter. First of all, I will start by disconnecting everything. So what I have is these massive cables coming from the battery. Let me get rid of them. Very important feature when it comes to these cables. Some people refer to them as welding cables. Look at that. I think these are the cables that are right for jump starting cars. Some people use AC cables. These are the right ones. Why? The resistance is completely minimal. And again, remember, when it comes to DC, a lot of current flows through these cables. So you need to ensure that you are careful with that. Now, another connection, or another important feature of this inverter definitely is we have the AC. AC connection for this inverter is very important point for us to take note. In fact, for that reason, I will just show that I take my camera all the way there, so that I may be able to demonstrate. Right. So down right there where we have AC output here, and then we have the AC in. So let me just get rid of these. So that is the AC, which is incoming. Yes. So at this point, my top boss allow me not to get rid of that because it's going to give me a lot of headache getting it in. We have AC input. So this is coming from the national grid, or if we are talking about a socket in the house that is dedicated to the inverter, we have this. So if you want to connect the inverter, the first things first, my top boss, now that the inverter has a battery connection, okay. So if you want to have a clear look of the inside, we have a lot of heat sinks. Look at that, massive heat sinks, massive heat sinks right there. Look at that, look at that. Why is it that big? You find your answer there. Look at that. Yes, running all the way, and then this paper ensures that there is a flow of air that is directional. All right. So our AC is off. We have connected it right there. Excuse me. AC is off, and allow me to connect them back by simply screwing that. Very important, we have the earth sharing. Earth is sharing. This inverter is connected to a very light load made of bulbs, okay, made of sound system, Wi-Fi, very light load. So we also connect the output. Now, let us first of all connect the battery, isn't it? Or before we connect the battery, we can connect the output because it is not fed, okay? And the output for AC is 0. So we connect our neutral at this point. Before switching the inverter on, especially if the AC is incoming, you must connect the battery. So you start with the battery, you go to other features, all right? So shall we connect the battery? Isn't it? All right. Now for you to connect the battery, Kibuka Michael says, my name is Kibuka from St. Joseph's Technical Institute in Uganda, and I'm an electrical student. Glad to have you join us. So the AC output is connected, the AC input is connected, but very important, it is not on. Will not power it on. Why? We have to first connect the battery. You first connect the battery. And so we have these two cables. Very important for you to note is that we will not connect these cables to the battery. We start because in the process of connecting it, to the inverter, you might short circuit them. So if they are connected to the battery, then it means that this short circuiting or bringing these cables together, closer together, or making contact, there will be a problem. A short circuit is defined as drawing very high currents from the battery within a very short period of time. Consequences: damaging the cells, especially for this type of battery. So DC plus, connect it to blue. Blue is our positive, and that is at the battery. DC minus, we connect black. Black is the color code for negative. So ensure that all the strands go all the way in for DC minus. Make sure it goes all in before you can screw it. Tightly do that screwing. You can see it is all in. When it comes to the positive, connect it as well, ensuring it goes all in as well. And then you tightly do that connection. Nothing should be powered on until all the connections are properly done. Now that my top boss, we have seen the inside, allow me to cover it. That is for safety reasons as well. You don't want me to be short-circuited while on a live stream. To be very unfortunate. How did you like the internal engineering of that inverter? If you are into electronics, I bet you found it very interesting, and everything is very clear to you. But if you are only into electrical, you probably were fascinated by it, and maybe some of the things that you saw you have never encountered. We will definitely have a session where we will talk about electronics. What is the size of cables run from the inverter to battery? What I have here is 25 mm. Good question from Chris Wambugu. Thank you so much for that. Very, very brilliant question. You notice that from the battery, from the inverter all the way to the battery, and in fact, that connection at the inverter, there is a very huge allowance for you to connect huge cables. That is done intentionally, my top boss, very intentionally, so that you can curb any chances of overheating. Why will those cables overheat? Simply because DC current, direct current, uh, requires huge sized cables because of losses. And especially if you're compensating for the distance, you must ensure that you compensate for that. So we will see to come in. We will not allow PV to come in. We have not even connected them. We will first connect our inverter to the battery so that it is not damaged in any way. All right. So move with me all the way down to our battery. We did a good job at ensuring that we crimp the cable lugs. So like we did, we also have to confirm DC plus is connected to blue cable. This is what we have. And DC minus is connected to black, and that is what is connected to, should be connected to the negative terminal of the battery. So all you need to understand is the color coding. The colors that you use must be consistent. At the inverter, we have blue as positive, and then at the battery, we have negative. I mean, we have black as negative. So we start with connecting black. And you must always ensure that the connection is completely, or it is very, very tight. So you start with one terminal, ensure that it is tightly done. I've started with the negative. So I will use my pliers. In the meantime, so Daniel Elegant, good to see that you have been here for quite some time. You have a question, and your question goes like this: top boss, in other types of inverters, is it the same connection? Aha, that is a very good question. In other types of inverters, we have so many inverter types, and we definitely need to understand which ones. So each and every company comes up with a different way of connecting their or manufacturing their inverters, and we shall be looking at that definitely. Right, so let me just bring my camera closer. So we go to the positive, the last one, connect it here. We also confirm at the inverter, is blue coming from positive before we can connect it, so that we don't short circuit the inverter. It will be tragic. And from what I can see, blue is definitely positive. Don't know whether you can see it properly. Blue is positive, black is negative. DC minus, DC plus, right? DC plus blue, DC minus black. I want to make sure that also at the battery it is consistent, because if you connect it oppositely, then you will have problems. You'll burn the inverter. So that being said and done, there is a spark release there, and you have to ensure that you do it very fast, very firmly. Tightly done. So I'm using this tool, very important tool, to ensure that the connections are very tight. Just ensure that everything is straight. DC cannot electrocute you. It is the good thing about DC, but very high voltages can. Very high voltages are dangerous. James Kahuho, good to see you. Samuel Energy Solution Limited, good to see you. It is very important when you see top bosses using names that can really identify with their profession. This battery and this battery. I have so many batteries here. All right. So let me focus, continue with our work. So if we were to switch off, to switch on the inverter, it will run and it will give an AC output, but not yet at the moment. Let us not connect it at the moment. Let us not switch it on at the moment. But if we did, we will definitely have an output at the AC. We can even take the, do you want us to do that or we connect the solar first? We'll then connect PV. So at this stage, we can comfortably connect, we can comfortably switch on the inverter. We can also comfortably get an output because our battery will definitely be giving an output right there. James Kahuo says, thanks for your teachings. Actually, I'm blessed with because I'm doing electrical engineering and I'm a student. Thank you. You're welcome. You're saying you're watching from Kitale. What part of Kitale, James? Kitale is my hometown. Chris Wambogo says to the solar first. So we connect the solar before we can power everything, isn't it? Before we can power it on. All right, makes sense. Makes a lot of sense. There is also something very important that I would like to bring to your attention. And it is definitely this cable. So let me just strip it. So you can see how the sheath has been properly done. Don't know whether lighting is enough here or need to enhance. Allow me to enhance our lighting. So how about that? Makes sense, right? Incredible. Yes, sir. So the battery is connected there. PV, we connect our PV. As much as I know the sun is down and it's we probably probably may not be able to get. So this is what I was talking about. This is the cable. As you can see, the sheathing properly done. You just cut it. And that is the sheath. Good job, good job. All right, so allow me to first of all tape it, because at this point we will not need the earth connection, but we can connect the earth connection from here to the earthing pole that is on the ground. So that is connected to the ground because the solar has to be earthed. The solar panels need earthing, right? So that one I'll be able to demonstrate on the ground with what I've with the projects that I've already carried out. Right, I don't know whether this one will be able to strip properly. Just use something else. Very important for us to note is this type of cable that is coming from the solar panels, the PV, is made of copper, right? And apart from that, has a lot of strands. That's like the battery cable. It has a lot of strands. This is a size number 10. Look at the beauty of engineering. Size number 10, multi-stranded compared to AC cables. That is a very important thing that you need to note. So that is for both the positive connection and the negative connection. Kitale town near Kitale Medium Prison. Thank you. That is James Kahuo. Good to see you, my top boss. I also have Idris, says I'm from Rwanda. Good to see you, my top boss. Thank you so much for joining in. So if we connect it at this point, PV plus, again we go with blue being the positive termination, and then black being the negative termination. Are you able to see my top boss? Let me just bring it closer. So at that point, we have PV. Just a moment, let me adjust my camera. So we have PV plus PV plus, we have PV minus. We will be connecting PV plus to blue, or blue will be our PV plus that goes all the way to the solar panel, and PV minus black, meaning that is a negative. Okay, I have negative and positive. That is what we have when it comes to DC. It's almost similar as live or line and neutral. Line and neutral when it comes to AC. All right. So again, you start connecting at the inverter before you can connect the panel, right? Then you ensure. If not, you have to repeat that. And confirm that they are tightly done before you can connect to solar panel. So my top boss, do you have a question when it comes to solar? If you'll be watching this video as a recorded version, kindly let me know on the comment section. What would you want us to tackle next when it comes to solar or solar power or solar energy generation? It's a very important topic. Every electrical technician needs to understand it, because in one way or the other, you definitely encounter a customer that requires the solar connectivity, and you must therefore be prepared to offer exactly that. When it comes, it's powered off simply because we have not connected the AC. So alternating current is not flowing in from the national grid, right? And we have done that on purpose. Why? Because you might bring a lot of trouble to the inverter if you try to do the other way around. So we have connected solar, but it is not on because I've not switched it on. The AC output is connected, no AC output. The AC incoming from this source is not connected. But now let us first switch the inverter on. Because it is connected to the battery and the battery has power, then it will definitely turn on. So it's setting itself up. That's why you can hear the beeps. The battery has already indicated it's on. The output is not yet there. There we go. We have the output. So what we have at the moment is the battery feeding the load, and that is why we have the battery connected to this indication. You see DC on one side, AC on the other side, meaning that that is inverter function, whereby you have DC from the battery, and then the inverter, it goes all the way to give an output, which is AC, alternating current. Alternating current, that is what we use on our sockets, the lighting that uses AC. All right. Is our solar connected? No. So if we connect our solar panel, you will definitely see PV connected. That is what you have. Are you able to see that? Perfect. So PV, that is a solar panel, has been connected. That is the right procedure. So you don't start connecting solar panels. No, you might damage the inverter, and that is why it is strictly done by someone who understands that connection. Now, if we feed the AC, we will see the AC incoming here. So that will definitely be the final step before we can cover here. So we can actually cover before, we allow the AC in. So I'll simply screw that. At top post, if you have already found value out of our today's session, kindly smash that like button. And if you have not subscribed to our YouTube channel, Top Heights Electricals, kindly subscribe so that you don't miss any of the live streams that are on the way, as well as the videos that we publish on a weekly basis, sometimes on a daily basis. So Top Boss, where are you streaming from? And I have a lot of friends from Ghana, Nigeria. We have our Top Boss from Nigeria already in the stream. A lot of top bosses from Kenya. I'm proud that I'm supported by my own. And for so many people who ask, John, where do you come from? I come from Kenya. So the only thing remaining now that we have solar in, we have the battery connected, we now have to power in or supply AC. Please show us the connection from the solar panel. That is Daniel Elegant. I will do that, but not at the moment. I will show you with a different panel. I will also do that from the ground. So from what I have here, the AC is coming in, it is being sieved or being checked. So the AVS has allowed it. You can see it is already on green, but at this point we also have that the inverter has not allowed it to come in. It is checking it. There will be a click sound. There we go. And having certified that the AC is coming in is okay, the inverter has to give that click. Definitely that means that it is a switch, which is an SP. Do we refer to it as a what? Not a contactor. There's another name. Small devices that are used for switching. They give a click sound. I'm forgetting the name. Kindly remind me. Yeah, so it has allowed the AC. So the AC is feeding the load. Something very interesting, you see that the solar panel as well as the AC that is incoming has prioritized charging the battery, so that at any given time, in case power will be out, that is the national grid or solar, the battery is full. But at the same time, the load has been prioritized by the AC or the incoming power supply, that is from the national grid, isn't it? So what remains here is for me to finish the wiring. But what we have seen my top boss all the way from the start is for you to wire the inverter, you must ensure that first the load is I mean the battery is connected to the inverter as we have done, right? My camera is too high even for me. Thank you so much. The likes, it means a lot, and even for engaging in the way of commenting, you know. So the inverter, for you to connect the inverter, you first of all start by connecting the battery. You know, you cannot reverse that process whereby you connect the AC or PV or solar. PV is photovoltaic. This connection here. Do not connect solar panel or panels to the inverter if the battery is not connected. You first start by connecting the battery, my top boss. Once the battery is connected, then you can connect the load. All right, you can connect PV, can also connect AC. But the hack here, if you are installing an inverter or a solar power system at your clients or at your home, the first process is to always ensure that the battery is factored in. The battery is connected first. Now, when it comes to disconnecting the entire system, maybe you want to transfer it, you want to shut everything down, you want to, repair the inverter. Now, the first procedure is if you have PV, shut down PV or the solar connection, the incoming connection from your solar, shut it down. Another thing that is very important, disconnect AC that is feeding the inverter so that you are only remaining with the battery at the end of it all. Another thing, disconnect the load, and then finally the battery will be last. All right, so it is like the opposite. While connecting the inverter to the various connections, the battery is always first to connect before solar panels, before the AC, before the loads. While disconnecting everything from the inverter for either maintenance work or probably replacing it with a bigger one or a more efficient one, the first process is to start with the PV and then disconnect the incoming AC, disconnect the loads, and finally disconnect the battery. All right, makes sense. Now I will still come up with more videos to explain what we have covered today in our live stream. I will share more when it comes to the inverter. Like you have noticed in our today's live stream, we have also showcased the internal features of the inverter. I will still share more when it comes to the components, probably the use. I will not have a lot of knowledge because I'm not that well versed when it comes to electronics, but I will try. If I get someone who will definitely be very conversant than I am to explain to us, I will definitely outsource them so that they can be able to share more when it comes to the components that are inside the inverter, my top boss. If it is something that there is something that would like me to talk about more, I will definitely do that. How to transfer switch the ATS wiring, I will definitely be doing that. Thanks Martin Carter for that. I have Chris Wambugu says, what about the connection from the solar panel to charger, controller, and automatic charger to solar inverter? I will do that when we'll also be talking about the MPPT solar charge controller. It will be a very interesting subject. Hmm. May you clarify the difference between the conductor and a cable? Conductors are normally bare, not insulated. The cable is insulated, at least for that is my understanding. There are other factors when it comes to a conductor. It is used for overhead transmission. A cable in most cases is used for underground or concealed transmissions. A conductor is used for longer power transmissions, while a cable is used for short distance transmissions. For instance, you have a conductor that is feeding the transformer. You have a conductor that is feeding a substation, all right? But you have a cable that is dropping power from the pole to property, all right, or to the meter box or to the meter board. That is a very interesting question. Thank you so much for that, my top boss. Now, allow me to end this live stream, this session for today, and check out our videos that are coming up. If you have any questions, I will be glad, my top boss, to hear from you, and I hope to hear from you soon, my top boss. My name is John Gatehi, and I am from Kenya, taking you through what I know, what I love, what I have passion about, which is electrical. And today's session has been fantastic, and it has been about the inverters when it comes to solar connections or solar energy. I've taken you through how to disassemble or how to disconnect all the connections in an inverter, and how to reconnect an inverter back in this entire stream. Let me know where you're streaming from. If you'll be watching this video as a recorded version, let me know where you are watching me from, my top boss. I love to connect with my top bosses from the UK, from Africa, especially in Ghana, Nigeria, Kenya, Uganda, Tanzania, South Africa, South Sudan, Somalia, Ethiopia, my top bosses. I don't know if I have forgotten your country. Just remind me on the comment section. But I thank you so much for your time. I thank you so much for all the attention that you give to me, especially on this channel, my top bosses. I salute you for being here. It means a lot. For all the questions that you have, let me know on the comment section. We will work on them one by one, my top boss, and I can guarantee you that this is your number one channel of value when it comes to electrical and electrical installations, my top boss. Thank you so much. My name is John Gatehi, and this is Top Heights Electricals and Electricians. See you in the next one. Goodbye for now. Idris says, I'm from Rwanda. Good to see you, my top boss. Joshua Mutinda says, top boss, may you clarify the difference between I've already done it? So glad to see. Arnold Masaire says, top boss from Zimbabwe. Good to see you. Chris Wambugu says, thanks very much for a great lesson for today. We meet again next time. Thank you, absolutely, Chris. And they also say, yeah, the same. Thank you. I really appreciate your time, my top bosses. Goodbye for now.